Okay, so day 2, same kind of thing we did before, except for now we might have to do a little bit with factoring. You might have to be using a few of these. You might have to use your trig formula sheet. So keep that in mind as we go through this. So the first one, you have to remember you're thinking of the trig function as your variable. So this is like having 2x squared plus x. And so if you had a quadratic like that and you wanted to factor it, you would take out the common factor. So we take out a cosine theta. So I'm left with 2 cosine theta for the first term, plus, I divide that by cosine theta, I'm left with 1. Alright, so it factors into that. Set each factor equal to 0. And so for the second one, when I set it equal to 0, I have to subtract 1, divide by 2. I get the cosine of theta is negative 1/2. So now I really have 2 problems like we had on day 1. I have to figure out what angle has a cosine of 0. Cosine of 0 when x is 0. So that's going to happen at pi over 2 and at 3 pi over 2. And we're still in that range between 0 and 2 pi. Where's the cosine equal to negative 1/2? Well, negative cosine is negative in those 2 quadrants. When cosine is negative 1/2, y is radical 3 over 2, so that is a reference angle of pi over 3. So that's going to happen at pi over 3. And in this quadrant, if the reference angle is, oh wait, cosine is negative, sorry, the reference angle is pi over 3. Cosine is negative in those 2 quadrants, so it's going to be 2 pi over 3. Sorry about that. And then if the reference angle is pi over 3, it's going to be 4 pi over 3. So 2 pi over 3 and 4 pi over 3. Cosine is negative. Okay. Number 2, same thing. It's like having 2x squared minus x minus 1. So I'm going to factor it like I would a quadratic. To get 2 sine squared, I have 2 sine times sine. To get a negative 1, I have to have a negative 1 and a positive 1. And if I put the negative 1 here and the plus 1 here, my middle term is going to be negative 2 sine plus 1 sine. I get my middle term of negative sine. So when I set each of those equal to 0, I get the sine of theta is negative 1/2. If I set this factor equal to 0, I get the sine of theta is 1. So where's the sine equal to negative 1/2? Sine is negative in those 2 quadrants. Reference angle would be pi over 6, because that's when I have x is radical 3 over 2 and y is 1/2. So if my reference angle is pi over 6, this would be 7 pi over 6. And this one would be 11 pi over 6. Those 2 answers for theta. Come over here, where is the sine equal to 1? That's when the y value is 1. That only happens in one spot on the inner circle, and that is at pi over 2. Okay? So you just factor those like you would any quadratic. Alright, with this one it's already factored, so all you need to do is set each factor equal to 0. So with this one I get the tangent is equal to 1. This one I get secant is equal to 1. Alright, where's the tangent equal to 1? Tangent is 1 when the x and the y value are the same. So if I take y over x, I get 1. So that's going to happen with a reference angle of pi over 4. Tangent is positive in those 2 quadrants. So theta could be pi over 4. Or in this quadrant, with a reference angle of pi over 4, there'd be 5 pi over 4. And then for the secant to be 1, that really means the cosine is the reciprocal of that. The reciprocal of 1 is 1. Where is the cosine equal to 1? It's equal to 1 over here. And remember, in our range of answers, it includes the 0, but it doesn't include 2 pi. So when I look at this and I say I have to name this, I can't name it by 2 pi because of that range. I have to name it as 0. Okay, because of that. It's the 0 is less than or equal to theta, which is less than pi at the top. Alright, now we got a problem with this one because I have a cosecant squared, so it's like having an x squared. This is cotangent. So the formula that we know that we don't need our formula sheet for is, what is the cosecant squared equal to? It's equal to the cotangent squared plus 1. That's one of the trig, the Pythagorean identities that we need to know. So now I subtract 1 on each side. We can do that first. And again, I have this like having x squared equals x. I first have to set everything equal to 0. To factor, I factor out a cotangent. And I get the cotangent is equal to 0, or the cotangent minus 1 equals 0, which means the cotangent is equal to 1. Alright, cotangent, remember, 0 is like 0 over 1. Cotangent is x over y. So if x is 0 and y is 1, or it could be negative 1 for that matter, where is the x value 0? It could happen there. That would give me a cotangent of 0, or 0 over negative 1 would still give me 0. So theta could be pi over 2, or 3 pi over 2. And then where is the cotangent equal to 1? Well, that's like saying the tangent is equal to 1. That's going to happen here and here. And again, it's 1 when x and y are the same. So that's going to be at a reference angle of pi over 4. So theta could be pi over 4. Or down here, it could be 5 pi over 4. Two answers for that one. Okay, so there you had to use the trig identity first to get everything in terms of cotangent, then set it equal to 0, factor out the common factor, set each factor equal to 0. Okay, same with 5. If you look at 5, you've got a sine squared, but you have a cosine term here. So we need to get everything in terms of cosine then. The only thing I can switch is here. Sine squared is 1 minus cosine squared. So you have to make sure that your squared term and your non-squared term are in the same trig function, so you have the same variable. So now it's like having 1 minus x squared equals 2x plus 2. So let's add cosine squared and subtract 1 to both sides of the equation. So I'm going to get 0 over here equals, I have a positive cosine squared, a plus 2 cosine, and a plus 1. So again, that's a quadratic we can factor. It's going to factor into cosine theta plus 1 plus 1. That gives me my middle term of 2 cosine. So I really have a double root there. So I only need to set cosine theta plus 1 equals 0, which says the cosine of theta equals negative 1. That only happens in one spot. That happens when theta is pi. It's the only place where the cosine, the x value is negative 1. So then we get my one answer there. Again, because that was a double root, it happens twice. Same root. Okay, and then the last one, we have to get in terms of sine or cosine somehow to solve. And if you look at that, this is 2 theta and that's theta. So we probably need to use our trig identity for that one. The sine of 2 theta, if you go to your formula sheet, the sine of 2 theta is equal to 2 sine theta cosine theta. So that's what I'm going to use. So I'm going to write this as 2 sine theta cosine theta. Now this is in terms of 2 trig functions, but I really can't do anything like the Pythagorean identities because nothing's squared. So the only thing I can do is subtract the cosine of theta, get that 0 like we normally do. And I have these 2 terms. They're not squared, but they have something in common. So I can factor out the common factor, and in this term I'd be left with 2 sine theta minus, in this term I'd be left with 1. So even though it's not a squared, I still can get everything set equal to 0 and factor it by factoring out the common factor. And then I set each of those equal to 0. So I get cosine of 0, and if I add 1 divided by 2, I have sine is 1/2. Where's the cosine equal to 0? That's the x value. That happens in two places, pi over 2 and 3 pi over 2. Where's the sine 1/2? Sine is positive 1/2 in those two quadrants. So that means your x value is radical 3 over 2. That's 1/2, so that'll be pi over 6. And with this reference angle, pi over 6, that would be 5 pi over 6. Okay, so the only one I really needed to use my trig identity sheet for was this last one, number 6, because of that 2 theta. And then this one was a theta, so I had to make sure I used that to get it in terms of theta before I could factor it. Okay, that's page 1.